Hello parents and students. Hope you're all doing well out there. Welcome to my YouTube channel. This is our first video. It's going to be on mathematics. It's going to cover area. This is video M1.1. M for math, 1 for the first week of school, point 1 the first video. I'm going to go over some simple vocabulary, and it's only going to be 2 words. First word is concrete. You may know concrete from what you see on the sidewalks or what they pour for foundations for homes. This actually has a couple meanings. We're going to use a mathematical meaning for this. The next vocabulary is abstract. This is probably a new word for you. Abstract means, well, dreams are abstract. They're hard to explain. So abstract is things that are hard to explain, and concrete are things that are easy to explain. So concrete is easy, and abstract is hard. In this lesson, we're going to practice that. We're going to start out with something that's concrete, and we're going to go to abstract. What we're going to look at math today is what's called an area. We're going to be looking at the inside of this rectangle. The inside of the rectangle can be explained using math, and that's called area. Again, we're going to start from something very concrete, and we're going to go to abstract. So let's get started. For our concrete example, I'm going to use crackers. Now these crackers have a particular shape. You already know this shape. It's called a square. And I'm going to arrange my crackers in rows and columns. You can do this as well. You can get some crackers at home and arrange them in rows and columns and follow along with me if you'd like. Pause this video if you want to get some. Now we're going to do a little math. I'm going to count these rows, and there's actually 3 rows. 1, 2, 3. I'm not going to count all the crackers. I'm just going to count the row. Up here, I have 4 columns. 3 rows of crackers going this way, 4 columns of crackers going this way. How many crackers do I have altogether? 12 is correct. 12 crackers altogether. Now I can show this in an equation, a math equation, and you're probably already familiar with this math equation. We're going to use this symbol here, the multiplication symbol, and I'm going to say 3, taking my number from here, times 4 is equal to 12. I'm going to add one more thing to this 12. Since we're talking about this shape, we explain areas in using this shape. And I asked you what the shape was before, and you said it was a what? You're right, it's a square. So I'm going to say 12 squares. I kind of ran out of room here. This is a concrete example of explaining an area. Now I'm going to get a little bit more abstract. I'm going to remove our squares. I'm going to have these later with some peanut butter. Or maybe some cheese. Now we've removed the crackers, and we're going from our concrete example to our abstract. We're still dealing with area, but we're going from concrete to abstract. Here's our area now without any crackers in it. There's no squares in here. We had 3 rows here, if you remember, so I'm going to draw 3 rows. How many columns did we have? 4 columns. I'm going to divide this in half first and then try and make my squares look square, just like the crackers that fit into them. Now remember, each one of these is a square. I'm going to use the abbreviation SQ for squares. How many squares are there in this area? We said, hey, there's 12 of them. 3 rows times 4 columns equals 12. What if I turn this way and I change our rows into columns and our columns into rows? How many squares do I have now? Have I taken any squares out? Have I added any squares? I have done none of that. I'm still using the same squares. We can express this in an equation also. We can say 4 times 3 equals 12, and I'm going to use my abbreviation now because I don't want to write squares out all the time. 4 rows times 3 columns equals 12 squares. So whether we can take these numbers and reverse them, change the shape a little bit, as long as we don't remove any squares, we have the same product, 12. When I talk about abstract, concrete to abstract, that's what I mean. We use crackers first for a concrete example. We took the crackers away, and now we're just using shapes as drawn on a piece of paper. This is called a model. Now we're going to make it a little bit more abstract. So we learned that this inside is the area, and we have on the outside rows and columns, but we aren't going to even write rows and columns this time. And I'm going to make up what our rows and columns are going to be. So let's say over here we have 4 rows, and up here we have 5 columns. What would the area be if we have 4 rows and 5 columns using our operation? In this case, we're going to be using multiplication. Can you write an equation showing me what our product might be here? How many squares would I have inside this area if I had 4 rows and 5 columns? Pause the video and work that out a little bit. I'm going to put as one of my factors 4 rows, and my other factor is going to be 5. Then I can multiply these. I don't even need to count the squares in the center anymore. I don't have to make my rows going this way and my columns going this way. I know that there's going to be 20 squares inside the perimeter, and 20 squares is going to fit into this area. I also know that I'm going to take my 5 columns and multiply that times my 4 rows, and I'm going to get the same identical product, 20. This would be correct. Now you're doing abstract math. You're determining the area just by knowing one side of a shape and then the other side of a shape. And all these shapes are going to be basically rectangles. So try this with your homework. You can practice using graph paper if you'd like. You hopefully will get some crackers and have some crackers and peanut butter while you're doing this. And I look forward to making another video for you later on.